Is it recording? Control G. Oh, yeah, it is recording. Okay, so the first one says, what is the mass of 1 mole? And you have to know that 1 mole represents the weight, where you're going to just take each atom. There's one Ca here, and then you're going to go to table elements, and you look up Ca right there is, the mass is 40. Okay, so then, yeah, take whatever you need. All right, so there's one of these. This can be on our email, on our video. And there's one sulfur, right? And there's 4 oxygens. So if you go to table elements, this is 32 for sulfur, and oxygen is 16. Let's see, where am I? Okay, so you put 32 for sulfur and oxygen is 16. And I rather you memorize that water weighs 18. Okay, 16, 17, 18. So it's 2 times 18. I just memorized water's weight. And then I just have to add it up. So in the calculator, I'm doing 46 plus 32. 4 times 16 is 64. And 2 times 18 is 36. And when I add it up, I get 178. So I don't know what happened here. Oh, because this is 40. I said 46. I was going to say, why am I off? Because I can't read my own handwriting. But that's how you do gram formula mass. So here's another one. There's 1 copper, there's 1 S, and there's 4 oxygens, and then there's 5 waters, and water weighs 18. So you're clear on what I'm doing. And we already looked up these weights. We just have to go to the table, find copper. It's right here at 63.5. So I'm going to put 64. Because these could be open response too. And then you just do 64 plus 32 plus 16 times 4 is 64, and then 5 plus 5 times 18, and the total weight is 250. So that's going to be at least 1 gram formula mass problem. So you're clear on how to do it. Do you need to do the third one? No. The only thing I'm going to tell you is there's 3 Ca atoms, and then you have to like move it over. There's 2 phosphorus, and there's 8 oxygen because you multiply. But I'm going to put the weights because I know them by heart, and I showed you where to look them up. Oxygen weighs 16, and then you just multiply and add it up. And there's no formula for this on table T. Now here, they want to know moles of oxygen atoms. Atoms is just the front number times the bottom, or the coefficient times the subscript. So there's an imaginary 1 in front here, and 1 times 3 is 3 oxygen atoms. That's easy enough, right? And okay, good. Now the next one, how many moles of atoms in 1 mole of this? So atoms, again, is when you add up each individual element and the quantity. So there's 1 N and there's 3 H's. So when you add it up, good. Now when you're given a reaction, you have to know that the moles is the number in front. The coefficients is 1 mole of Ca, 2 moles of water, 1 mole of this guy, and 1 mole of this guy. Okay? So when you're given a reaction, you're going to set up a ratio. How many moles of water? So you look in the problem and you put an X on top. Needed to react with 2 moles of Ca. You find Ca in the problem, you put a 2 on top. And then you're going to do mole to coefficient ratio. So you're going to do 2 over 1 equals X over 2. And when you cross multiply, you get X is 4. Okay? Next one, given a reaction, they want to know moles. So that's where you're going to do the mole to coefficient ratio. It's not on table T. How many moles of NaOH? So I find it and put an X. Need to react with 2 moles of this guy, so put a 2. And then the ratio here, if you look at the coefficient in front, is X over 2. And here it's 2 over 1. And when you cross multiply, you get X is 4 again. It's just a coincidence that they're both 4. Now here they want the mole to mole ratio between nitrogen and hydrogen. And moles is just the coefficient in front, so it's 1 to 3. Good? Good. Now here, how many moles of oxygen? So because you're given a reaction, I put an X. React with 8 moles of Al, and the ratio would be 8 over 4, X over 3. And when you cross multiply, you get 4X is 24. So X is 6. The answer is 6. And here they want the ratio of oxygen, which is this, so we need a 5 on top. And it represents moles, not grams. And then propane, they're telling you the reactions between propane and oxygen, so this has to be the propane. But it's a mole to mole ratio. Now, this one is with grams. You're probably going to get this. With grams, you just got to know the grams on the left have to equal the grams on the right. You might get one of these as open response. So here it says, what's the mass of this guy's calcium oxide? So I'm going to put an X on top. that react with 88 of this and to give you 200 of this. So all you have to do is, it's the left side has to be equal to the right side. And when you add this up, it has to be 112. So it's just setting it up. Again, no formula, nothing. Now here's another one. Determine the mass of washing soda. And it says here washing soda is this guy, so I'm going to put X over here. But it gave me 3,360 of him. 3,360. And they gave me 360 of water and 880 of CO2. So if you notice, on the left you have 3,360, and on the right side of the arrow you have X plus 360 plus 880. So you're just solving for X. And I'm not going to do the math because the answers are at the end. Here's another one. You have 1170 of NaCl, so I'm going to put that on top. And you have 460 of Na, and they want to know how much Cl, and I just know that with grams, the grams on the left has to equal the grams on the right. So I'm just going to do this one because it's easier. I'm just going to subtract, and I get 710. Okay? Now, when you are given moles with no reaction, that's when you go to table T. And if you look here, the formula for moles is given mass over gram formula mass. So that's when you're given grams, you're going to actually do, oops, I lost where we are. Grams given over the gram formula mass equals moles. Okay, so they gave you 1.5 moles. They're asking you mass, which means grams. And you could do the weight. The gram formula mass is always known. You have 1 carbon and 2 oxygens. And if you go to the periodic table, carbon weighs 12 and oxygen weighs 16. So we could go back here. Oops, wrong thing. 12 and 16. And when you add that up, it's 12 plus 32, so it's 44 grams is the weight. So, and if you think about it, in order to solve, you got to cross multiply here. So 44 times 1.5 will give you 66. So you're going to get a few of these. Here's another one. What's the mass? So that's grams of 25 moles of acetylene, and they gave you the weight. So the formula on table T is moles is given mass over the GFM. And just to show you one more time, that one's right here. When you're given grams, you could use the formula. And then you're just going to do 25 over 26. And that's right, because it's, oh wait, no, I did this wrong. They want the mass. I was like, wow, that's weird. They gave you 25 moles. We don't know grams, and they gave you the gram formula mass. So you cross multiply here. I'm going super fast so we could work on other stuff, but is this a good pace for you?
Yes.
Okay. So here's another one. How many moles of CO2 in a 220 gram sample? And there's the gram formula mass. But based on the formula, it's grams given over the GFM. So you just do 220. You're either going to multiply the numbers or divide them if you have to guess, you know. Okay. Good with that? But you're going to get a mole problem like that. Now this one is another one where you got to do the mole ratio and mole ratio. So I'm going to leave those blank because the answers are at the end. And then I want to do types of reactions now. So I'm leaving a few blank for you to do if you want. Now here, if you have 1 going to 2, you're breaking it up, so it's called decomposition. Decomposition. I can't spell today. If you have 2 going to 1, it's called synthesis, which I don't see here. And this one, double replacement, is when they're all compounds. And there's 2 things on each side. So you see how this is all compounds and there's 2 on each side? That's double replacement. This is single replacement where NA's alone and H is with the O. Now NA's with the OH and H is alone. So single replacement, you're going to have 2 things on each side also, but you're going to have elements and compounds. This one with the carbon with oxygen, that has a special name. That's called combustion. You have to memorize all these. These are chemical reactions, because you just know the products are always CO2 and water. But you see here, that's an element, that's a compound, because it's made up of 2 or more. Then you have another compound here and an element. You see how you have 2 things on both sides, but because one guy's alone, That's single replacement. Mg's alone and Ag's with the NO3. Now Mg's with the NO3 and Ag's alone. That's single replacement. This is one breaking up into two things. You see that? You remember the name?
Yeah.
Decomposition, right? And here, this is 2 going to 1. 2 going to 1 is the opposite of decomposition, and it's called you're making something, synthesis. Now, 3 types of chemical reactions: decomposition, double replacement, synthesis. This condensation is gas to liquid. Solidification is liquid to solid. So they're tricking you. Those are phase changes, which is a physical change, not a chemical change. But you just have to know all those words that I went over with you, because you're going to get a few of those. So this one went 1 going to 2. Do you remember what that one was called?
Decomposition.
Yeah, decomposition. Let's see, this is 2 going to 1. So that one's called synthesis. And then this one's single replacement, this one's double, because he's alone and he's with the NO3. Now he's alone and he's with the NO3. And here, double replacement looks like this. If you put the 2 guys on the left on top of each other and they switch, now K's with the Cl and H is with the OH. What type of chemical reaction is this one? You have 2 going to 1.
Decomposition.
Well, decomposition is breaking up. It's 1 going to 2. It's the opposite. Synthesis. Yeah. 2 or more substances combine to produce a single one is
synthesis.
Yeah. Now, empirical and molecular. Remember, empirical formula is the most reduced. So most reduced. This guy, if I divide by 3, I get CH2. So it looks right, C1H2, and that's what we have here. They want to know which has the actual and the most reduced. Molecular means actual, so you're going to have to know these definitions. Which is both empirical and molecular. Molecular means the actual, and empirical means most reduced. So it has, if it's empirical, it has to be the most reduced. It's like water. Water is the actual, so it's the molecular, and it's empirical. But if they say which is empirical and molecular, you're just really looking for empirical. Because this guy could be divided by 2. Here you could divide by 6. Single replacement, I'm looking for 2 things on each side. And it's A because you have an element and a compound element. This one is 2 going to 1. That's synthesis. 1 going to 2. Decomposition. These are all compounds. So it's double replacement. Because you're definitely going to get 1 or 2 of those. Now, empirical formula here is the most reduced. First, I got to count how many C's there are. 1, 2, 3, 4. There's 2 O's. And I have 3, 4, 5, 6, 7, 8 H's. That's the actual or molecular formula. So I could divide everything by 2. So it'll be C2OH4. Good?
Mm-hmm.
2 types of chemical formulas are empirical, molecular. See, these are types of reactions, not formulas. Formulas are the actual or the most reduced. What's the empirical formula for glucose? And they said this is glucose, so we could divide by 6. This one's definitely going to be on the midterm. So it's C1H2O. They always put that one on. This is almost all the math. Now, this formula is hard to know. You're just going to have to memorize it because it's not given. The molecular formula divided by the empirical. Wait, let's see. What is the molecular formula of a compound that has a mass of 42 and empirical of CH2? You would get the weight of the empirical. Carbon weighs 12. We looked it up before, and hydrogen weighs 2. So you're dividing, I say the molecular weight that they gave you, divided by the empirical weight, and you get 3. So now I know I got to multiply the CH2 by 3. Really, if you forget the rule, just find the answer that weighs 42 and you'll get it, but it's C3H6 right there. Bless you, by the way.
Thank you.
Yeah.
I have a question. For the math midterm, do you think they're going to scale it?
Yeah, they will.
Curve it?
They will curve it, yeah.
So, like, there's a lot of kids fail, though, like...
They will curve it, but
passes?
if Farrell, lots of times a lot of kids end up failing, unfortunately. Their test is so hard. Yeah.
Even if they curve us?
I'm not sure, because I think they have to curve it if everybody fails. And usually they do, unfortunately,
I don't know why they made it so hard though. Like,
they do it every year. That's why, like, I was like trying to find like every possible question
whatever
they could
Heinz
ask.
gave us wasn't even on the test.
No, unbelievable.
And he's not even in school.
That's crazy. We'll see what happens. Hopefully they have to curve it if everybody fails. They always curve it. Carbon weighs 12, hydrogen weighs 2, so you get 14, right? So then you do 56 divided by 14 gives me 4. So if you want the molecular formula, you have a choice. You could just find the answer that weighs 56 because they gave you the weight. Or if I do it this way, if I memorize this formula, I know I have to multiply this guy by 4, and I do that. But if I check, carbon weighs 12, hydrogen weighs 1, and 48 and 8 gives me the 56. So you see how you could literally, because it's multiple choice, just find, like here, find the one. They're telling you that the actual weight is 70, so you could just find the one that weighs 70. But otherwise, you do me. You have to memorize that. 70 over, this was 14. We got that weight before. And then, because you're going to get at least one of these too. And you get 5, so you have to multiply that by 5. But this is the one that weighs 70 anyway. Now, is this reduced or not reduced?
Not reduced.
So when it's not reduced, it's the actual. I think of the molecular looks like the word multiple.
Yeah.
Like, okay. And then percent mass. Okay. Percent mass, you're going to get that one. And that one, the formula is here. Most, if you see, most of the math you have to know with no formulas. Percent mass is mass of part over mass of whole times 100. So let's do a few of these and then we're almost done. Like here, there's 2 waters, and I told you to memorize water weighs 18. So it's water's weight, because it said mass of part, over the total weight, which is the gram formula mass. So you didn't even have to add it up, times 100. So there it is. How about here? They want the percent mass of nitrogen. So it's part over whole times 100. So there's 1 nitrogen, and there's 3 hydrogens. And if we go to the periodic table, hydrogen weighs 1, nitrogen weighs 14, so that's 14, that's 1. So the total weight's going to be 17 when you multiply it out. So how do you get the percent mass? Nitrogen's weight over the total weight times 100, and then you plug that in. You do. There's no equal sign, so you're not cross multiplying. You're just doing 14 divided by 17 times 100. Oops, I didn't hit divide in the calculator. I get 82.3, so there it is, 82. Next one, carbon weighs 12, we looked it up before. Oxygen weighs 16, so the total weight is 44. So we need a 44 on the bottom, so it has to be that one. But anyway, it's carbon's weight, because they want the percent of carbon, over the total times 100. And carbon, there's only one of them in this problem, so you do that. Good?
Yes.
And that's basically all of the math.
That's not bad.